In this video, we're going to discuss finding x-intercepts of any function. Now, right now we are in the middle of quadratic functions, but finding x-intercepts of any function is the same no matter what type of function you have. So no matter what function you have, remember function just means for every input there's only one output, and the x-intercepts of any type of graph, let's say this is something you haven't seen yet, okay, it's called a polynomial function, but x-intercepts are always just where is your graph hitting the x-axis. What's special about the x-axis is, on the x-axis, y is 0. So when you are trying to find your x-intercepts, what you want to know is, what is x when y is 0, or when the output is 0? So if I have a quadratic function, okay, let's say negative x squared plus 5x plus 2, and I want to find that function's x-intercept. So I want to know what are the x-intercepts of this quadratic function. What I want to know are, what are the values of x, okay, so what is x when the output is 0? So what you are doing is you are just solving, okay? You are solving a quadratic equation. If it's a quadratic function, that's now set equal to 0. So you now have the standard form of a quadratic equation. So now all you have to do is, okay, how should I solve? This is in standard form. What's my best approach to solving? Well, this isn't factorable, so I shouldn't try and factor it, okay? I'm gonna use the quadratic formula, or I'm gonna complete the square. I'll just use the quadratic formula. So negative 5, x equals negative 5 plus or minus the square root of 5 squared minus 4 times negative 1 times 2 all over 2 times negative 1. So it's going to be negative 5 plus or minus the square root of, now remember, simplify this chunk, simplify the discriminant, so that's going to be 25 plus 8, so that's going to be 33, all over negative 2. Now, usually you would keep your answer exact, but if I said that the x-intercepts are negative 5 plus the square root of 33 over negative 2, and negative 5 minus the square root of 33 over negative 2, and I asked you to graph those x-intercepts, it's not going to be easy to graph those, okay? So when you are talking about x-intercepts, it's okay to round your answers that you're getting here. So I'm going to go over rounding your answer. So the first thing we round is, what is the square root of 33? Okay, so the square root of 33 is approximately 5.745. Okay, so we now have negative 5 plus 5.745 all over negative 2. So this is going to be one of the x-intercepts, and we want it rounded because most of the times we're going to want to graph it, okay? Shouldn't say most of the time, but it will make more sense when I say a decimal answer as, oh, this is the value when y is 0, as opposed to saying, oh, the value of x when y is 0 is negative 5 plus the square root of 33 over negative 2. You really can't put context to where that number is. But if you see it as a decimal, you can. So remember, you do the numerator first. So if you put this all in your calculator, you need to make sure you're putting parentheses around the numerator and then hitting divided by negative 2. Okay? If you just do this, if you put this in your calculator like so, order of operations, your calculator does order of operations. It follows the law. So it'll do division because division is higher up on the hierarchy in order of operations than adding. But what this expression says is you do the numerator first and then you divide it by negative 2. So that's going to give us negative 0.3725, or negative 0.373 since I did 3 decimal places here. So that's one of the x-intercepts. And now the other x-intercept is negative 5 minus 5.745 over negative 2. So make sure you do minus, and make sure you do not do that, okay? So that's going to give us 5.373. So that is our second x-intercept. So what are the two x-intercepts? The two x-intercepts are negative 0.373 and 5.373. So these are the two values of x that are rounded that when you plug them in will give you an output of 0. So that will be the values in which they are hitting the x-axis. Okay? So now I'll just go over one more quadratic problem. So that was in standard form, okay? And if we add f of x equals negative 3 times x plus 5 squared minus 4. Actually, I'll do plus 4. I'm going to do one more problem after this. So notice this is in vertex form, okay? And if I want the x-intercepts, I still want to know what are the values of x when the output is 0. So I want to know when is my input going to give me an output of 0. When you know what the output is and you want to know what the input is that gives you that output, that's when you're solving an equation, okay? So notice you have vertex form set equal to 0. Notice vertex form, you've got your x nestled into the square of a binomial with no other x's roaming outside. So you can, if you don't want to expand this and put this in standard form and use the quadratic formula, you can use the square root property on this problem. The first step is take away 4. You get negative 4 equals negative 3 times x plus 5 squared. Divide by negative 3. You're trying to take the square root. You'll be able to take the square root of this x plus 5 squared. So you get 4/3 equals the quantity of x plus 5 squared. You take the square root of both sides, and you get x plus 5 equals plus or minus the square root of 4/3. Okay, so you would get x equals negative 5 plus or minus the square root of 4/3. So it's going to be negative 5 plus the square root of 4/3, and then negative 5 minus the square root of 4/3. So once again, if I ask you, oh, plot these, those aren't too easy to go ahead and plot and make sense of. So round them. So just make sure when you put this in your calculator, okay, once you hit the square root button and it does that open parenthesis, make sure it's 4 divided by 3, then close the parenthesis, okay? Make sure 4 divided by 3 is in the square root. So negative 5 plus 4/3 is negative 3.845, and negative 5 minus the square root of 4/3 is negative 6.155. So those are your two x-intercepts. So your x-intercepts for this function are negative 3.845 and negative 6.155. Okay, and I want to go over one more. Okay. X squared plus x plus 1, I have a quadratic function. I want you to tell me what the x-intercepts are. Okay, so that means what are the values of x when the output is 0? Okay, so I'll use the quadratic formula. This isn't factorable, so negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 1 all over 2 times 1. It's going to be negative 1 plus or minus the square root of, that's going to be negative 3 over 2. Okay, this is not a real number. If this is not a real number, that means there are no values, there are no real values of x that can output 0. So what does that mean? That means that this function has no x-intercepts at all. But that's okay. That just means it looks like this or it looks something like this. Okay? It just means that it has no x-intercepts. If you go to solve for x-intercepts, you set equal to 0. If you find out that there are no real values of x that output 0, that just means that there are no values of x, okay, that can ever give you an output of 0, which is acceptable. That's a fine, because look at this quadratic. It never hits the x-axis. That means it has no values for x that can ever give you an output of 0. This is its minimum value it can hit. This is a maximum value it can hit, so it can never hit 0. Okay, so just know how to find the x-intercepts of any function.